everyone. This is Farm Coder's channel. Today we'll work on leetcode 3224, the minimum array changes to make differences equal. So this is a leetcode medium problem. Let's first see what this problem is about. So we are given an integer array names of size n, where the n is even, and also an integer k. And we can perform some changes on this array names. And in one change, we can replace any element in the array with any integer in the range from 0 to k. So we need to perform some changes so that the final array satisfies the following condition. So there exists an integer x such that this number is valid for all I in this array. So I larger or equal to 0 or less than n. Okay, we are required to return the minimum number of changes required to satisfy the above condition. So for example, for this one, so the final integer x will be 2. So it means the difference, the absolute difference will be 2. And in order to achieve that, we will replace, because this one and the first one is already 2, right? 3 minus 1 is 2. And 4 and 0 is not 2. So we change names 1 by 2. So this is 2, 2, and this is 4. So 4 minus 2 is 2. And for this pair, we need to change 3. Change 2 to 3. Then 3 minus 1 is 2 again. So the output is 2. Okay, so I think you can go through the second example by yourself. And the constraints are on the order of 10 to the fifth, and n is even. Okay, and k is also on the order of 10 to the fifth. So how to solve this problem? I think an distinction is we can try to have the difference and frequency pair, right? Frequency pair for all the pairs in names. Okay, then we notice the fact that if we have D1, F1, and D2 and F2, then if D1 equals D2, then what will happen? We just need to check the minimum of F1 and F2. Okay, so we just need to check this min, because this min will be always better than this max. Okay, why? Because if you notice the changes, there are two conditions. One is you can only change one number to achieve the difference. The other situation is you need to change both numbers. Okay, so the less d is, then the less operation you need to change. Because if the d is too large, if the d is too large, okay, I think I mistype here. So this is actually if f1 is f equal to f2, then we only need to check minimum d1 and d2, right? Because for two pairs, if they have the same frequency, then we only need to check the one with the less difference. Because if we can make some changes to satisfy the less difference, then we can of course make the same or more changes to get the larger difference, and vice versa. Okay, then let's write the code. So first we record n equals names size, and for each I equals 0, I less than n plus plus I, we remember the we use the unordered map to remember the div and the frequency. So this is h. Then let's say the div is abs names n minus I minus 1 less names I. And actually here we can say it's less than n minus I minus 1. Okay, because this is even, n is even, right? Then h div, the count will plus plus. Then we look for all the values in h, auto, div, frequency in h. Then we actually want another map to record all the to record all the frequency and minimum d. Okay, so this is if hh count frequency, then hh free equals div. Okay, otherwise hh free equals div. Yeah, I think then we have all the setup. Then we can have a function. We call that calc. Then we pass 3 variables. It's names d and k. Okay, then return value is int max at beginning. Then for auto, free, and div in hh, we have t equals calc names div and k. res equals res t. Return res. Okay, then n is the size, and for int I equals 0, I less than names n minus I minus 1 plus plus I. First we get the absolute value of abs names n minus I minus 1 names I is minus names I. Okay, then we say if there are two situations. One is if x equals d, not equals to d, we do the following, right? If it equals to d, we don't need to change anything. So if the max of names n minus I and names n minus I minus 1 is greater equals to d, or the minimum of names I and names n minus I minus 1 plus d less equal to k. These situations means we just need to plus 1. Otherwise, we'll need to plus 2. res, and we need to define res here. Yeah, let's see. Compile error. Okay, return should be somewhere here. Yeah, let's submit. Okay, it works. So what we will do is we notice the fact that we record all the difference and their corresponding frequency. And for two pairs, if they have the same frequency, we only need to check the one with the minimum diff. Then we can write this part. This part is to calculate the diff and frequency pair. And this part is to get for each for the same frequency, we get the minimum of the diff. And for each diff, we do the calc. Calc is to calculate the number of changes needed. And in order to get the number of changes needed, we check for each position. And if the position's diff is equal to d, we just ignore it. Otherwise, we have this if else. This condition means if one of the value is very large, right? If it's large enough, then we just need to change the other one. And if one of the value is small enough, then we can only change, we only need to change the other one. Okay? If they are not large enough or not less enough, then we need to change both. Then res will plus 2. Then finally we return res. Okay? And I think that's all for this problem. Thanks for watching. See you next time.